We're starting this unit, ICT PRG 405, automate processes. And this is the second unit discussing programming. In previous terms, we studied the unit ending with 407. In this unit, we have 8 topics. So as you see here, we have algorithms, then modular programming. Inside the algorithms PowerPoint, there is a revision for what we have studied in the previous unit. Also, this PowerPoint about manipulating files is related to, or this is a revision of what we have studied in the previous unit. Then we have writing methods and of course exercises. Exceptions testing. This is the 4th topic. Then we have debugging, documentation, network APIs. Then we have other modules and other points related to programming in Python. The depth of knowledge we are going to, it is not, of course, similar to being a programmer. To become a programmer, you need to study for at least 1 year programming languages. Algorithms, it's a huge subject. I have studied algorithms for in my studies for a year, so it is not an easy thing, but for our cybersecurity, the need is understanding the meaning of algorithms. So when you log into Connect, you will find the PowerPoint. It's called algorithm, but it includes, as we mentioned, it has a revision, then algorithm. So we did this revision last week. So I will start from the algorithm. Please go through this revision, and if you need anything, let me know. We can discuss that in class time, or even we can have makeup classes, additional classes. We can discuss further details. So what is the algorithm? As per the definition, it's an unambiguous sequence of steps that must be performed to solve a problem in a finite amount of time. So we need to solve a problem, and to solve this problem, we need an unambiguous sequence of steps. Good. If I'm telling you now I have a flat tire and this is a problem I'm facing, you will tell me to change a flat tire. You need to go into sequence of clear, precise, specific steps. Starting with maybe opening your boot, get the spare tire, or before that even check that you have a spare tire, and so on. If I'm asking you, okay, I'm designing a robot, and this robot in a restaurant, it will cook the perfect steak every time. So the robot will ask through a programming or a software, piece of software you create in Python. So the software will ask the guest about what type of steak they want. Is it medium rare, medium well done, or whatsoever? So we have different inputs here. Based on that input, the robot will cook the perfect steak every time, following the sequence of steps. So we have some specific steps to get the perfect steak every time. At the same time, we need to think about errors in input. So if the robot asking me, how do you like your steak? And instead of telling the robot medium, I will tell the robot, my name is Sam. So different input, the robot never expected that. The application there never expected that. So it may hang or it may do some crazy stuff. And this is what we see in different situations with other applications when it hangs or even it accepts some inputs, wrong inputs, and so on. So we need to make sure that the algorithm will handle the wrong inputs or misleading inputs or any malicious code we type in. So we need to think about that. Okay, so here they are using some examples about chocolate bars and calculating that. We have some characteristics of a good algorithm, and it must be accurate, efficient, and scales well with the size of the problem. So accurate must always solve the problem correctly. If you are calculating the salaries every fortnight, so it has to be accurate every fortnight, and we keep repeating that. It should solve the problem with the least amount of CPU activity, memory usage, and input and output. So the less steps, the better performance. And why is that? Because we might reach the capacity of the computer or even more than that, and this might lead to some challenges. Scales well with the size of the problem. So we hired new employees, so the system can handle also the calculation of their salaries. So it should grow with the growing number of employees. So this is the point we need to understand related to the meaning of scales well with the problem. So here again, the algorithm is an unambiguous sequence of steps that must be performed to solve a problem in a finite amount of time. At the same time, it has some characteristics, should be accurate, efficient, and scales well with the size of the problem. Here we have this figure just representing if we have lots of inputs, so the performance could be affected because we need high performance and lots of data to handle and process. Now, the differences or the relationships between algorithm, pseudocode, and comments. Each time you have a problem to solve, you need to think about a suitable algorithm to solve it. And we are getting the algorithm from either we draft an algorithm ourselves, then we can improve that, or as a team, we discuss the algorithm, the logical way of solving a problem, and telling the computer to follow our logical way. In many cases, we search for an algorithm online in different forums, then we can improve on that. Then after finding and choosing a suitable algorithm to solve the problem, we need to write the algorithm in pseudocode. Then we will translate the pseudocode into programming language. Here we are using Python. Then we are using the pseudocode as comments in for the bulk of data or comments. So all these steps, of course, will be carried out by the computer. Now we have 5 minutes activity. In this activity, I want you to think about how can we solve this problem. So how can we design an algorithm? So I'll explain the activity and give you like 5-7 minutes so you can think about it on a piece of paper and share your thoughts on the chat, or you can unmute your mic. Then we will explore further. So what is the problem we have? We have on paper a list of 1 million people's names and their bank account balance. Thousands and thousands of sheets of paper sorted by the surnames of the people. We need to design an algorithm to find the name of the person with the highest or the largest bank account balance. So this is the core algorithm I want you to get and think about. In an unambiguous steps, must complete infinite time sequence of steps. So you need to come up with an algorithm to do that. Of course, we can do that in computers, and if you want to think from a computer point of view, so imagine that you have all these data in a table or in an array or list or database, CSV file, whatever the digital format is, how we can find or find the name of the person with the largest bank account balance. So I'll give you 5 minutes from now. So yeah, 5 minutes, 6 minutes passed. The whole idea here is we are storing this data into boxes or storage areas, and we are comparing each two. Then we swap, and we keep repeating that. So this is the logic behind the algorithm. So let me show you what we have. So this is called bubble sort, and here just search that online. So we have the first pass. Let's say we are starting with 4 digits. Then we are comparing the first 2 boxes. Then we are swap. Then the second and third. Then swap. Then third and fourth. Then after that we go back again from the beginning. Then repeat, and so on, and we keep repeating. This will give us the final result of the alphabetical order or the numerical order or whatsoever. This is a little bit bigger number, so 5 instead of 4. And as you see, again, we keep comparing 2 boxes by 2 boxes, 2 storage areas, variables or whatsoever, then until we reach the end. Then we repeat again, and first pass, second pass, third pass, and so forth. So where's the bubble sort here? Let me show you if we have 10 random numbers and we sort. So it will keep comparing 2 by 2, then swap to reach the end, then try again, and done. If we have like 100 keys, so it will work like that. Start building the sequence. So this is like animation for the bubble sort algorithm until we reach the end. It's this code in Java, but if we go here, we have the here they are explaining what we are doing, and we have the algorithm here. Then the code. So this is what's so-called bubble sort, and the algorithm and the logic behind that. Do we need to go deeper than that? No, we don't need, because we are not programmers. We just need to understand a little bit about algorithm and how we design that. Okay, so this is the part related to algorithm. Here in Connect, when you click next, then we have week 1 exercise. Really good idea to try to do these exercises. So for the algorithm, we have comparison for 2 values in exercise 1. Then exercise 2, we are reflecting on the Python script. Then we wrote here. So it asks you for the if the algorithm will terminate in a finite amount of time. Is it correct? Is it unambiguous? And so on. Then here, another one in exercise 3, we will write a Python script to read in a line of text from the user, examine the text that the user entered, and print out a summary of the text. So we have some hints here. Again, this exercise, it is not assessment or quiz or anything, just exercise for you to try yourself. You still have access to the unit content from last term. So feel free to go back to this content or also use Discord to chat about that. Then we have exercise 4. So 1 or more loops in your code. So does the structure of your code conform to the definition of an algorithm? And some checks here, some questions and so forth. Exercise 5, set of integer values in a Python list. Then write script that starts with this list of values and convert the bubble sort algorithm into Python. Then you run that. The not an algorithm description of bubble sort is swap adjacent values. If they are out of order, repeat the above action until no swaps were done. So this is exercise 6. Really good idea if you try few of these exercises today after we finish the session, and maybe the rest you can do during the week in your own time, or even during class time, and you can share it with all of us on Discord. So it's really good thing. Okay, everyone. So I'll just refer to our main reference for this unit. We are using the book, Automate the Boring Stuff. Just a moment. And remember this one. So the YouTube channel, Automate the Boring Stuff with Python, and also we have the book for automating the boring stuff. This book. So automatetheboringstuff.com. So the book is available online for free. You need to read the part related to input validation, reading and writing files, organizing files, debugging. So these 4 chapters are very, very important for the current unit. So make sure to go through them and also the videos. Okay, everyone, is there any question for me? Any question? Good, I'll stop now the recording. We'll take 10 minutes break, then we'll come back for the rest of the class.